welcome here to Cranky Calculus. We're going to cover some tough subjects here, some implicit differentiation, related rates, and a couple of other things in between. The reason I'm doing this is because these are problems that I've given to my students from years past, and that they've struggled on, and there's some things here and there I'll make sure that we kind of touch up on. This is to help you do better, help you to study, so make sure you like and subscribe to get more content like this. I'm here at Cranky Castle, and let's get rocking and rolling here. Problem that we got going on here is going to be a FRQ style implicit differentiation question. So we have the curve C, and we want to find dy dx. So looking at this curve right here, we're going to go through and differentiate implicitly because we do not have a y equals equation. The y is embedded in here. So as we do this, I'm going to kind of go underneath each one. We're going to go 2x for that first term there. Now you have to be careful. There is product rule coming up on this. It drives me crazy that students cannot still figure out product rule. We have an x times y. That's going to be product rule. So as we do this, the first is going to be first. So we're going to have 1 times y plus x tag the derivative of y dy dx plus 2y dy dx for the y squared equals, what's the derivative of negative 3? If you said anything other than 0, you are going to need some help because derivative constants are 0. Do not forget that. Now I'm going to do a little bit of cleaning up here, and then I'm going to collect all my dy dx's. So on the next line here, I'm just going to just distribute that negative 4. Make sure you distribute that negative 4 all the way through, so we get minus 4y minus 4x dy dx plus 2y dy dx equals 0. So what we're going to do here is we are going to move all of my non-dy dx terms to the other side so that I'm left with negative 4x dy dx plus 2y dy dx equals negative 2x plus 4y. I'm going to kind of slip this over here because I have a little bit more room. Once I do that, I can take out a GCF of dy over dx, and I'm going to have this negative 4x plus 2y. That's going to equal negative 2x plus 4y. Divide both sides by that negative 4x plus 2y. I'm sure y'all love just me watching me write the exact same things over and over again. But as a final answer here, well, maybe not final answer, we can clean this up just a bit. We're going to get this ratio of negative 2x plus 4 all over negative x plus 2y. If I do make any errors, you're going to have to let me know in the comments so I can go ahead and make any corrections. But I can divide out a 2 on the numerator and the denominator here, and so that we get a final answer of negative x plus 2y all over negative 2x plus y. Problem here, same prompt, same curve. Find the tangent line of C at that point 7, 2, and then use this tangent line to estimate the y value when x is 8. So just to give you a friendly reminder here, that is our point slope formula. We do have x1, we do have y1. We do need to find the slope, and the slope is going to come from plugging in my x1 and y1 into my dy dx. So my slope is going to equal dy dx. Make sure you're good at communicating here, and you are literally putting down what you're doing. And this is what this says is I'm plugging in 7 for x and a y for 2 in my derivative. So when I do that, I'm going to get negative 7 on top plus 2 times 2, which is the y value, all over negative 2x. That's going to be negative 7 times 2. I'll just switch up the order because I really have no clue. So the top there is going to be negative 7 plus 4, which is going to give me negative 3. The bottom there is going to give me a negative 14 plus 2, which is negative 12. So I'm going to end up with a 1/4. So now my tangent line that I have here is going to be y minus y1, which is 2, equals the slope, which is 1/4, and then x minus 7. Now, with this tangent line, I'm going to estimate the y value when x is 8. So I'm going to kind of transform this into y minus 2 equals 1/4, 8 minus 7. When I do this, I'm going to end up with the 1/4 on the right hand side. So my y value is going to end up being 2.25 because I'm going to add 1/4 plus 2. So that is my estimated y value whenever I go through this process. For part C here, we're going to find the x values where C has a vertical tangent. So we're going to come back up to this dy dx that's boxed up there, and we're going to make sure that the denominator equals 0. So that's the whole point here. So we are going to check to make sure that 2x, so no, it's negative 2x plus y is equal to 0. And I want to make a quick note here that the numerator is not equal to 0. That's something that a lot of people forget. A lot of students forget that. Even some teachers forget to teach that. That is graded as is on the AP exam. You do need to be aware that only the denominator is 0 and not the top. When we go ahead and solve for x here, are we okay if I just kind of skip the semantics of the algebra here? We get x to equal y over 2. And then we're going to plug that back into what our prompt is up here, that x squared minus 4x plus y squared, to solve for our y value. We could also solve this for y equals, actually it's probably easier to do this, y equals 2x. I think this is the easier route to go because I do want to find the x value. I don't care about the y value. So when I plug this back into this equation, oh boy, we're going all over the place here. When I plug this back into this implicit equation right here, I'm going to get, see if I can remember this, it's going to be x squared minus 4xy turns into 2x. Is it plus y squared? So plus y squared is 2x, that's all squared, equals negative 3. I'm going to end up with x squared minus 8x plus 4x squared minus 3. Actually that's x squared. When I combine all that, what do I end up with here? I'm going to end up with negative 3x squared equals negative 3. Oh, that is my alarm to take out my garbage. We'll just leave that in the video. So you're going to get x to equal plus and minus 1. Okay? So x is equal to plus and minus 1. That's the thing I care about. Now, I do want to real quickly just double check to make sure that that is not true for either x equals 1 or negative 1. So I real quickly will check if x is equal to 1, that means that y is 2. And if I real quickly come up here and plug in x equals 1 and y equals 2, that is why am I going back up there? I'm lost. My garbage alarm really threw me for a loop. I'm going to plug this back into what I just started right here. So it's going to give me a negative 1 plus 2 times 2 cannot equal 0, and that's true. That works out. When x is equal to negative 1, y equals negative 2. Plug that back in real quick, and I'm going to get 1 minus 2 times 2, which is not equal 0. So that checks. So both of these are valid x values. Going into this last part here, is going to be a little bit of related rates here. Find a particle, a particle moves along the curve C. At the instant the particle is at 2, 7. dx dt is negative 3. Find dy dt at this moment. So we're going to go back and implicitly find this equation. Again, I'm just going to reiterate it for you. Believe this is it. If this is not, you can comment below that I just wasted my time and I wasted your time. Very confident that's it though. So let's go ahead and take this derivative of this, but now let's tag everything with dt's so that we can have this as a related rate. So first derivative is going to be 2x dx dt minus 4. Pull out the minus 4 there. Just make sure life's so much easier so we don't forget this product rule when we mess it up. This is going to be dx over dt. Y plus x, I'm messing this one up, plus x dy dt plus 2y dy dt equals derivative of negative 3 again is 0. I'm going to go ahead and just start plugging everything in. I know that x is 2, y is 7, and dx dt is negative 3. When I do that, I'm going to get 2 times negative 3 minus 4. I'll distribute that here in a second. Dx dt I have is negative 3 times y is 7. Plus we have x here, which is 2 dy over dt plus 2 times 7 dy over dt equals 0. So my first term there, I'm going to end up with a negative 12. I'm going to distribute that minus 4 all the way through. So negative 4 times negative 3 times 7 is positive 84. And distribute that negative 4 again to that 2 dy is going to end up with negative 8 dy dt. And then plus 14 dy dt. I'm going to get some favorable numbers here because that negative 12 plus 84 is going to turn into a 72 plus 6 dy dt equals 0. I'm going to kind of spare you the algebra here, and I think it's very clear that dy dt is equal to negative 12. That means that this particle is falling at this time. All right, and that's going to wrap up our very first problem. To a implicit problem here where we do have a bit of chain rule and some obscure functions. I'd say very obscure since we're implicit here. This is not going to clean up nicely. It's going to be a little bit ugly, but we got to be able to deal with the ugly here in calculus. Don't worry about cleaning it up. Some teachers want everything to look nice and pretty. That's not what we're about. Just so you know, when teachers say to simplify, that's their opinion. It's actually not what is correct. So I'm not simplifying anything when we're done here. Solve for dy dx in terms of x and y, and we're done. Hopefully you know your derivatives of arctan. So this is going to be 1 over 1 plus the argument squared. So the argument is xy squared. Inside that argument is going to be the chain rule, and we do have a product rule within that. So I'm going to go derivative of x is 1 times y plus x tag dy dx equals, and then I'm going to go 1 plus the derivative of the ln is going to be something over y squared. Derivative of the inside is 2y, tag it, dy over dx. You could have easily moved the 2 off the y in front of the ln. You'll get the same result anyway. A little bit of cleaning up here is going to be, I'm going to distribute on the left hand side. So I'm going to get y over 1 plus x squared y squared plus distribute again. I'm going to get x over 1 plus x squared y squared times dy over dx equals 1 plus 2 over y times dy over dx. Move all my dy dx terms to the left side, move everything else to the right side. So I'm going to be left with this x over 1 plus x squared y squared dy over dx minus 2 over y dy over dx equals 1 minus y over 1 plus x squared y squared. So I'm going to spare you some of the algebra here. Let's go ahead and get to the final answer. You should all know how to divide out a dy dx. If you do not know how to divide out a dy dx, you're going to need to go watch somebody else's videos on how to do algebra. We don't have time for that here at Cranky Calculus. So a dy over dx is equal to, the numerator is going to be 1 minus y over 1 plus x squared y squared all over the x over 1 plus x squared y squared minus 2 over y. If I did anything wrong, you better leave a comment. I'm cool with this. To me, this is simplified. It's my opinion. Simplification is all an opinion anyway. And here is a problem that is geometric. Related rates can be very difficult for some people here. So we've got this problem dealing with cylinders, and we're going to have volumes and surface areas to deal with. Let's go through this problem. So we have a tube here being compressed while maintaining a cylindrical shape. The height is decreasing at a rate of 1 centimeter per minute. At the instant the radius of the tube is 9 centimeters, the volume is decreasing at a rate of 144 pi centimeters cubed per minute. Find the rate of change of the surface area of the cylinder at this instant. So what's really nice and fortunate is we're going to get these formulas, what that volume of a cylinder is and the surface area of the cylinder is. So real quickly, I'm going to want to kind of state what I have, what I need to know. So I know that the height is decreasing, so I'm going to call that dH over dt. I'm going to put all my givens over here. Decreasing, so it's -1. I know that the r is going to equal 9 at a certain time when the dv dt is 144 pi, and I want ds over dt. So since I want ds over dt, I'm going to take the derivative of this s equals equation right over here. So that's going to be ds over dt equals, and we're going to have product rule here. We have to be able to see this. This is important. If you cannot find out the product rule, you're going to have a bad time. So the derivative of r is going to be dr dt times h plus r dh dt. Now, of what I have for my givens, I have dh dt, I have r. I have not used dv/dt yet. I need ds dt, so I'm actually looking for two things here. I'm looking for dr dt and I'm looking for h. I need both of those things. So I have not used the volume yet. I'm going to treat that as my helper equation. So having the volume here is my helper equation. But again, I don't have information about volume, but I do know that dv/dt is 144 pi. So I'm going to take the derivative of this. So dv over dt equals, this is going to be another product rule that we have to be sharp on. Okay, so this is going to be a pi on the outside, and then I'm going to get 2r dr dt times h plus r squared dh dt. Okay, so from here I'm going to plug in some of my givens. So I have the 144 pi, then I have pi times 2 times r, which is 9, and then I have dr dt times h, I don't have those, plus h squared, which is 9 squared, times dh dt, which is -1. I'm going to divide both sides by pi here. Really, I can just cancel them out, and I'm going to get 144 equals 18 of these dr dth's. And then I'm going to have 81 times -1, so minus 81. Add 81 to both sides. I'm going to end up with 225 equals 18 dr over dt times h. And I'm hoping right now you start to recognize, wait a minute, I don't have dr dt, I don't have h, but I can start to pull some strings together here and start to manipulate with what I underlined over here. I'll underline it again in red on the blue, and maybe I can substitute out both the dr dt and the h. So divide both sides by 18. Not the cleanest number in the world, but both of those are divisible by 9, so I'm going to get 25 over 2 is equal to dr dt times h. So I'm going to go ahead and take this value and substitute it in over here. So this is going to be 2 pi times my 25 over 2 plus r, and I have r, which is 9. And then I have dh dt, which is -1. And this is what ds dt is equal. I have everything now, and I'm totally good to go. I am going to distribute that 2 all the way through. So I'm going to get pi times 25 minus 18, because I'm going to get 9 times -1 times 2 is -18. And that's what ds dt is. So my ds dt final answer here is going to be 7 pi centimeters. It's centimeters, I think, right? Yeah, centimeters squared, because it's area, per minute. If I made any typos here, it's totally possible. I might have made some issues here or there arithmetically. So if you see any issues, comment down below. And let's get rolling to our final problem. This problem that we have here is one that I gave years ago, and a lot of people got it wrong from an assessment of mine, and I think the reason is because it was a little too simple for them, and they kind of mess it up. So kind of be careful about these related rate problems that are actually pretty simple. So let's go through this. A child 1 meter tall is walking directly underneath a street lamp that is 6 meters above the ground. The child walks away from the lamp at a rate of 20 meters per minute. How fast is the child's shadow lengthening when the child is 2 meters from the base? So pretty much you have, I'll draw this little lamp right here. Just deal with it. And then we have this child. Child's a stick. Deal with it. And then what's happening here is, if you understand this picture, we have a shadow right here. I'm going to kind of darken it. So this is the shadow right there. Here's a child. So I'm going to use S for shadow. I'm going to use X for how far away the child is. This pole is always 6, never changing, so it's keeping as a constant 6, and this child is also 1, also not changing. Technically the child's growing, but like whatever. We'll just assume the child is staying 1 meter tall at that moment. And so now I need to find a way to relate all these things with my givens. Really all I know here is that my dx dt, which is my distance between my child and my lamp, walking away, is going to be 20 meters. I also know that x is going to be 2. And I don't even know if that stuff's even useful. So I'm going to make a relationship of these two. These are similar triangles. So I have a small triangle, s over 1, equals the large triangle right here, which has this entire side of s plus x all over 6. So if I were to clean this up just a bit, what if I multiply both sides by that 6? I'm going to get 6s equals s plus x. Subtract 5 from both sides. I'm going to get 5s equals x. Okay, I'm ready to take the derivative of this. So I'm going to do that in purple here. When I take the derivative of this, I'm going to get 5 ds dt equals 1 dx dt. I have 20. Let's go ahead and plug that in. I'm going to get 5 ds dt equals 20. I know what you're thinking right now. You're like, wait a minute. There's no way it can be that easy. It totally can be. Just read through the problem, and sometimes you get too much information. Like for this one, we have an x equals 2. Who cares about that? That actually changes nothing with what I have. So this answer here, when I divide both sides by 5, is going to give me a final answer of ds over dt is equal to 4 meters per minute. And that is going to wrap up this review of related rates and implicit. Make sure that you like and subscribe if you want to see more videos like this. If you have any questions or anything, leave comments. That way I can answer them. Any ideas with other videos, please let me know. I am here to help you. That is my job here.